Hello everyone. In this video, we're going to introduce CLAMP Cancer, which is a special version of the CLAMP natural language processing tool devoted to the extraction of cancer-related attributes from pathology reports. The main difference between CLAMP and other clinical NLP systems is that it provides both pre-built high-performance NLP components and a user-friendly interface for efficiently building customized NLP pipelines for information of interest. Here, we demonstrate how to build a customized NLP program for extracting primary site, histology, biomarker, and tumor-grade information from pathology reports using CLAMP Cancer. To build such an NLP pipeline, we need to follow these steps. First, create a new pipeline project by selecting various NLP components. Second, configure the pipeline by customizing the selected components. Third, specify the input files that you want to analyze. Fourth, process the selected input files by running them through the pipeline. And fifth, review the outputs of the pipeline and refine it by going through steps 2 through 4 again. So now, let's create a pipeline project called CLAMP Demo Cancer. Now let's add components into the newly created pipeline. Go to the pipeline panel, go to the folder that you just created, open the components folder, and double-click on the clamp demo cancer.pipeline file. Now, you need to drag and drop the NLP components from the component panel onto the pipeline window. CLAMP Cancer comes with general NLP components such as a tokenizer, sentence boundary detector, as well as a number of cancer-specific components under the Named Entity Recognizer folder. Each of these will help you extract one type of concept that is related to cancer. Here, we add 4 types of entities. The primary site component represents the primary organ or tissue where the specimen comes from. The histology component will identify the histological type or morphology of a cancer. It will show the origin and nature of the tumor. The biomarker component will extract information related to the immunohistochemical tests and their values in the report. Using the tumor grade component, you can extract the grade of the tumor as well. We drag and drop the components from the Components panel onto the pipeline window. You will notice a red X sign next to the name of the folder. This sign indicates that the component is dependent on other NLP components that are missing from the current pipeline. To fix this issue, simply click on the Autofix button at the top of the panel. This will automatically add the required components to the pipeline. Please note that the sequence of the individual components from top to bottom reflect the order in which they will run to process your input data. At the end, you will need to add the relation extractor component, which is also listed as one of the NLP components. This component allows you to finalize your pipeline process and extract relationships among the different concepts. At this time, the pipeline is configured with the default settings of each component and it is ready to run. However, you often need to modify the settings of each component in order to achieve optimal performance on your specific tasks and your local data. Let's go through an example of how to modify the settings for the primary site component. Simply double-click the config.conf file to open it in the middle window and modify the parameters that you're interested in. For example, you can replace the default dictionary file with your own dictionary file by clicking on the 3 dots button and selecting your file. You can also add new terms to the dictionary by clicking on the primary site.dict file from the pipeline panel and adding your desired terms. If you check the checkbox for case sensitive, the matcher will differentiate between capital and lowercase letters when searching for a term in the dictionary. If you check the checkbox for stemming, the matcher will match the stemmed form of a candidate named entity with the terms in the dictionary. Similarly, you can completely customize regular expressions, rules, and relation connections by either editing or replacing the default configuration file provided. You can even annotate your own corpus and train your own machine learning models to replace the default model if you need to do so. Now that the pipeline is configured, let's save it. Now that we're ready to run the customized pipeline, let's import some pathology report files into the input folder. Now we're ready to run the pipeline on the input files. To run a pipeline, simply click on the Run icon at the top of the screen. Once the pipeline starts running, you can check the progress of the process from the console window and the progress bar at the bottom of the screen. Once the process is completed, the generated files are displayed in the output folder. CLAMP outputs are available both as XML or tab delimited files. Clicking on a file with the .xmi extension allows you to view its original content annotated with recognized clinical concepts. Different types of clinical concepts will be highlighted with different colors. For example, here you see that bladder and prostate have been identified as primary sites, and poorly differentiated has been identified as a grade. If you see any errors, for example, an important concept that is missing, you can go back to the pipeline configuration to adjust the settings. If you have a gold standard annotated dataset, CLAMP can also automatically report precision, recall, and F measures of the developed NLP pipeline. Thank you for watching this video. For more information, visit our website at clamp.uth.edu/cancer.